Brian Gockel here, Weather Service Office of Ops. Wanted to welcome everyone and thank you for all participating. We see, looking across the little icons here, that Carl Dierking is with us. He'll be giving us the presentation today. Also with us today is Dave Riddell, who's going to be a longtime ally of us for satellite projects, is going to be working with us to moderate the questions at the end of Carl's discussion. As you heard the prompt there, as I did, that the session is being recorded, just keep track of it so we can replay the presentation for others. So it'll be the usual fare, roughly a 15-minute presentation, followed by 15 minutes of Q&A, which Dave will moderate. Encouraging your questions to be posted in the chat room, and they'll be read from there. Dave is with us from WFO New York up in Upton, so welcome. And I want to make a call out, as we always do, for future presenters. The TELRES team, David Blutis and Lee Byerly here, I have working with folks and have a good lineup for the next few weeks. But we're always looking for others to who are interested, and we're interested in hearing from you related to satellite projects and products you're working on or techniques that you use in your office. So you're definitely definitely welcome there. And the training team has helped with the training materials that might today be unavailable, and Brian Mata has been an ally of ours in that department. So we've got, I want to thank the TELRES team, OCLO, and GOES-R program. It's been another ally of ours for over a decade. Matt Siebold and others there, always staunch, steadfast, and trusted partner, as well as the JPSS program as well, as we're building a stronger alliance with them. Carl has worked for the last 6 years up at GINA up in Fairbanks. Prior to that, he was prior to retiring from the Weather Service, he was SU at Juneau. He had nearly 40 years with the Weather Service, starting with WFO Jackson, Mississippi, and then to the Hurricane Center, and then many years after that in the Juneau, Alaska area. And he's got an interest in remote sensing and meteorological impact, complex terrain. And on a personal note, I've had the pleasure and honor of working with Carl. He's working on an arrangement that the Weather Service Office of Ops currently has with GINA up in Fairbanks, and he's part of the team that's helped us stabilize and shore up polar orbiting and satellite antenna that was put up with Sandy funds and called Sandy Dog, and that enables our Alaska region offices to. It's one of the systems that brings in a lot of Alaska region data from the polar orbiting satellites, and Carl is part of that team, so it's been a pleasure working with him. And so welcome, Carl, and if you're ready to proceed, we are interested to hear your presentation.
Okay, well, thank you, Brian. As you said, my topic is satellite products for aviation, and some of the conditions, the unique conditions that make them applicable for the high latitudes in Alaska and popular. Just to set the stage a little bit, Alaska has some unique transportation challenges. This is a map showing our road system, and you can see it's not very complete. There's great portions of the state that are not accessible by road. And one of our longest roads, the Dalton Highway, connects Fairbanks to Prudhoe Bay, the oil fields. I think ice road truckers, it's predominantly gravel road. Not all of them are in that condition. Some are much better, but obviously aviation and marine routes are critical to commerce and transportation between many communities in the state. And these modes of transportation are susceptible to extreme weather and topography issues, which contribute to delays. Alaska is an allude word for great land, and it is great, but the observations are not. We have a limited number of observations. These two examples On the left are density of surface temperature observations between Alaska and the CONUS. And then on the right, the radar coverage in the CONUS versus Alaska. In the CONUS, it's pretty well covered except for a few holes, and in Alaska, it's just mostly holes. So as a result, satellite data is really the go-to form of observations to fill those gaps. These are just a sample of some of the polar orbiting LEO type satellite products that are available at Weather Service offices from GINA data. Many of these, in particular the RGBs, are available in GOES versions at CONUS offices as well. But I'm going to talk about some specific examples as we further on in the talk. When we think of observation expectations, for satellite data, we have to consider that the needs vary. There's commercial versus private, instruments versus visual flight rules, and then a whole variety of equipment. And all these are operating in Alaska: floats, skis, wheels, and so forth. But among them, there are common data expectations. The data should be extremely timely and highly detailed. Quality can have life-threatening impacts. And in most cases, observations are preferred by aircraft operators. When possible, updates en route are certainly desired, but not always possible. So when we think of the high latitudes, it's really kind of a LEO-GEO mix for systems that are approaching from the south. The GOES 17 is a great source, 10-minute frequency updates, and great selection of bands and resolution. But when you talk about Arctic systems, it's really starting to diminish in its usefulness, and that's where LEO comes into play. There's significant resolution degradation, and there's parallax displacement issues as you get further to the limb. And then GLM doesn't work above 50 north. LEO has very high resolution. In the case of VIIRS, 375 meter resolution and minimal parallax. And some interesting additional sensors such as microwave, day-night band, and the microwave sounders that ATMS and the CRIS sounder that contribute to NUCAPs. But LEO relies on multiple polar orbiting satellites to kind of fill those gaps. And of course, normalizing between different sensors and such can be challenging. So GINA does have access to these multiple LEO satellites. The table in the lower left shows a list of the satellites that we're currently accessing and the sensors. Just to give you an idea of what kind of coverage we can get in our far northern portions of the state, this is a dayland cloud RGB. Just from VIIRS data, that's two satellites, SMPP and NOAA 20, 375 meter resolution, and we get in that area 16 to 18 passes a day every 50 minutes. So you can see it's fairly complete and highly detailed. GOES 17, it's actually surprising that you can get some information because of that 10-minute resolution, but of course it's highly pixelated, and of course we have the parallax issues. GINA has access to multiple satellite downlink resources. We have the antenna at the university campus, and the one, as Brian mentioned, at the NESDIS facility at Gilmore Creek, just north of Fairbanks. We also have access to NESDIS antenna data at Utqiagvik, or what was formerly Barrow. And so these three antennas give us redundancy, which allows us to access multiple satellites and have some backup capability. We have a near real-time processing system, which can produce products very quickly. So we receive data as it's passing overhead and turn it into products. Connectivity to the Weather Service office via LDM. So typically we can deliver products to the users within 15 to 25 minutes. We also produce imagery for non-AWIPS users as well. So to talk a little more specifically about products, the cold air aloft issue was brought to the attention of the JPSS NewCaps initiative a number of years ago, almost more than 6 years ago, I guess. And the problem was related to identifying regions of cold air of minus 65 degrees or lower that can cause potential freezing of jet fuel. The JPSS team assembled a collaborative effort, included CIRA, Sport, and SIMS, and came up with a solution using gridded NewCaps. Jack Dostalik produced some of these graphics that CIRA still provides in the upper right corner, showing areas of cold air aloft. And Emily Berndt and SIMS collaborated to provide a means of displaying gridded NewCaps in AWIPS, and that capability has progressed through the years. This allows a way for viewing cold air aloft both horizontally and vertically. And the results can be seen in the upper left. It's an advisory for cold air that the Alaska Aviation Weather Unit will put out in addition to their SIGMETs and AirMets. Volcanic ash is a big topic and one that's probably worth one or two presentations on their own. So I'll just touch on it briefly here, but anything to do with volcanoes probably has Mike Pavlonis involved. He's done a lot and done a lot in this state. We are very sensitive. We have at least 50 active volcanoes and potentially more. And then we're located close to Kamchatka, which can receive ash drifting our way as well. So it's a considerable problem and an extreme hazard for aircraft. Mike has developed satellite products that include height, ash height, loading, probability, and he's currently working on AI techniques for warning on volcanic ash. There are some RGBs that are available. VIIRS has an ash RGB, and there's a GOES version as well, and an SO2 RGB that is primarily GOES because it relies on water vapor imagery, although we can produce those in MODIS, which has water vapor channels. GINA also receives direct broadcast OMPS data, which can produce SO2 maps. In the lower right is a image of SO2 that was observed from the Raikoki volcano that erupted in July of 2019. Tony Wimmers has done a lot of work on identifying gravity waves and relating that to aircraft turbulence. Wimmers and a SIMS team there, which includes some people you probably are very familiar with, Jordan Girth and Scott Bachmeyer, Scott Lindstrom, etc. And Scott has also blogged about this, but the Alaska Aviation Weather Unit has found this to be very promising and is utilizing these techniques for identifying turbulence in the Alaska area. It's primarily GOES, but as I said, we do receive some water vapor imagery and MODIS, and sometimes we receive enough to identify waves from that. I guess the challenges are what are the best high pass filters, and how do you relate these gravity waves to impacts on different aircraft types. Experimental icing products. This is a project that that NCAR is currently working on. It's funded by the FAA Air Weather Research Program, and they distribute icing, the icing product Alaska directly to the Alaska Aviation Weather Unit. They found it to be very promising in advising for icing conditions. They do supplement it with other data, including the NewCaps soundings. And there are other potential products like ClaverX Cloud Phase, which I'll talk to in a minute, and MIRS, the microwave product suite, which includes a cloud liquid water product. So speaking of ClaverX, this is a a suite of products that are specifically presenting characteristics of clouds. There are LEO versions and a GEO version. And it is the focus of the JPSS Aviation Initiative. The principal investigator is Andy Heidinger and his SIMS development team. And it's based on NOAA enterprise algorithms. And there's a link to a little more detail on these products, but they include cloud top heights, cloud base heights, cloud phase, cloud type. Those are kind of the more interesting of the set. There's actually a few more that I don't have shown here. So the JPSS Aviation Initiative was formed a few years ago, designed to improve NOAA's satellite products for aviation. And these cloud products are kind of one of the focuses of the Aviation Initiative. And they would like to increase the use of them among aviation interests. And the team is developed to provide a feedback mechanism for aviation users. So if you look at the team members, of course, there's government agencies, Weather Service, FAA, and so forth, and CIs, but also the Alaska Airmen's Association and the Alaska Owners and Pilots Association. And these members are very active and very interested in some of the results. We did a demonstration project in 2018, and it was generally well received, but one of the outcomes was that PlanView products, which was all that we were presenting during that demonstration, the PlanView products were somewhat difficult for non-meteorologist pilots to use, and they required interpretation. So that kind of led to the development of the cloud vertical cross-section products. In this case, the developer is Juneau from CIRA. She uses the NOAA Enterprise Cloud Retrieval. These are put together by connecting cloud top and cloud base heights from SMPP and NOAA 20, and then coloring them based on the cloud top phase. Freezing levels are obtained from NWP and NewCap's temperature profiles, and then pilot reports are plotted when they're available. These are cross-sections along fixed routes that are the more popular routes between cities in Alaska. Ideally, at some point, this would be a more dynamic tool where you could pick your own route. But right now, these are fixed routes. So this summer, we're conducting another demonstration product, which is focusing mainly on these on the cross-sections. These are considered a pre-flight briefing tool. It's experimental, but it's to give you an idea of the weather to encounter en route. There are training and display tools that are based on user feedback and ongoing efforts to improve the displays as we get more comments and suggestions. We are grateful to the aircraft operators for their participation in this. So, in summary, aviation is an important means of transportation and commerce in the high latitudes, and it's mainly because of the great distances between communities and the limited road systems. The large size of the state and limited observations make satellite data a critical tool, and there's very strong interest in the aviation community for these observations, but the product needs can vary. And because of that great demand, Alaska becomes an excellent test bed for developing these products. And like I said, the JPSS Aviation Initiative is currently evaluating these Clavrex vertical cross sections in a demonstration project this summer. So that's it. I have a few references which are by no means comprehensive, but just a few, if you wanted further information, you could kind of take these and go from there. And that's it. I'm ready for any questions.
All right, Carl, thank you so much. So I just shared a feedback survey. We certainly encourage you to please share your feedback on this session in the SBC. I just put that in the chat room. You could follow that link there. And at this time, we would like to open up the question and answer session and discussion. And with that, I know, as Brian mentioned earlier, we'd like to introduce Dave Riddell, the SU from the WFO in New York, in Upton, and I will turn it over to Dave for the question and answer. Dave?
All right, great. Thanks, David. Carl, great presentation. Every time I look at the number of taps that I see up in Alaska there, it always, causes me to pause and blink twice. One question, I guess maybe I can leave this off. One question I had for you was with respect to ceiling and visibility preparation for the TAFs. Do you all have, and perhaps you will with Go 17 once this product becomes operational here in the fall, the probabilistic flight category in terms of prob, MVFR, IFR, LIFR, that I believe there is also a polar version of as well. I guess, have folks up there utilized that at all, those products at all, and if so, how have they been received?
That's a question I can't answer. Currently, I'm not in the weather office to know what they're currently using, but I suspect that it's probably still, there's still some issues with that. It's highly variable. The GOES data, of course, is more reliable, but then, you have the resolution issues. The LEO data is more reliable farther north. So to approach the problem, it has to be kind of a blending approach. And I think while there's a promise in that, I'm not sure that it's quite there yet to kind of take the benefits of both and make use of them.
Okay, great. A question from Brian Mata here in the chat. Is GINA using any special GIS techniques or displays for use in satellite products for aviators?
Yes. There are a number of products that are provided for GIS. The table of plan view products that I showed in the first slide on Aviation Initiative, this panel here, these are all provided in GeoTIFF format, and other products that have been identified for GIS users. We turn those around when requested.
Okay, great. Another question I had, given Go 17 and the meso window that's parked up over there, I think for much of the time, have folks found utility for the 1 minute data for aviation purposes that you're aware of?
Oh yeah, absolutely. The meso window is very useful. But again, it's a question of latitude, right? So if you move too far north, you get 1 minute data, but it's very pixelated, so the usefulness begins to diminish. So it's more in the southern portions and the panhandle part of the state where it's most useful.
Okay, great, thanks. Another question here for you, Carl. Can any of the findings from the JPSS Aviation Initiative demonstration be applied elsewhere, do you think, either in CONUS or perhaps parts of Canada?
Well, yeah, absolutely. And YJ at CIRA has developed a prototype page for the CONUS. See, I think I have a slide here. So it is entirely possible. Obviously, again, this is an issue with kind of a GOES versus LEO kind of approach, but it certainly is something that could be related back to the CONUS. There is some questions, I guess, regarding how non-technical users interpret products, and the FAA, I know, does not. They frown on products that require a lot of interpretation by pilots. It's a little more like red, green, yellow, yes or no, go. So interpretation is something that we have to be very careful about and try and keep these as simple as possible and focused on their use in pre-flight planning and maybe less so for actual advisories in flight. But it really depends on the products, and it depends on the location, and of course the difference in aviation users.
All right, great, thank you. And as a reminder, I see all the attendees on here. If you do have a question for Carl, go ahead and stick it in the chat, and we'll try to answer those. Carl, another question here. Do you anticipate a GeoXO type of geostationary platform focused on the Arctic to be useful for aviation operations?
Yeah, that would be a great addition. I think Canada has explored the option of the highly elliptical orbits, something that would have much higher frequency of coverage. That's really what is needed in the far north. And the GeoXO program is just now kind of exploring different options for that. But anything that would improve the frequency of data as you get farther and farther into the northern latitudes would certainly be a valuable asset for Alaska in general.
Okay, great. Another question here, and I guess this maybe gets at the Twin Otter versus the 7.4. Should the impact of aviation hazards identified by satellite be calibrated for aircraft differences, such as equipment, size, the speed, and those sorts of things?
Yeah, yes, and but it really depends on the on the focus of the product. Turbulence, for example, is going to have much different impacts, but then the size of the aircraft, the different aircraft may not be in regions that turbulence are affecting. So you have to account for the altitudes, the size of the aircraft, many of those things. Clouds and visibility are a factor for all different shapes and sizes. I think that's one of the more critical weather factors for aviation, and is certainly one of the leading causes of accidents. And so that one is probably not so much a need to differentiate. But some of the things, icing, turbulence, those issues really are dependent on the variations in the equipment.
Okay, great. Last question that I have, and you sort of touched on this, I think, already. But in your opinion, GEO-LEO perspectives for aviation products, should they be merged to try to take advantage of the strengths of each?
That would be the ideal. There's challenges. With the cloud products, if you think of parallax is dependent on the distance from nadir and the altitude of the cloud feature. And with cloud products, the altitude is part of the result. So parallax could already be accounted for, but you still have issues with resolution, pixel resolution differences, and timing. But ideally, it could be these challenges could be worked out, and trying to bring this into some sort of consensus that would really help for the northern latitudes in particular.
Yeah, and I would just add, and I tend to agree with that perspective, and is something that I've always tried to kind of highlight as well. I would add, in addition to just satellite-related products, things like NWP and or gridded analyses where appropriate. I think that's what has made things like Prob Severe and even some of the flight category Prob flight category products that are kind of this hybrid between imagery and model analyses or even an hour or two forecast, working off the strengths of all of those pieces, kind of make for the best products. This idea of fused data, even if it's not entirely satellite based, is one that we've always tried to advocate for. So appreciate that. At this point, I guess we can take any. Go ahead.
I just wanted to add that, yeah, that's kind of the exciting thing about GeoXO approach is we're no longer having to deal with two separate entities. We're trying to bring this into some sort of merged outreach or initiative. So hopefully we can bring these things together more as time goes on.
All right, great. I think we're at the top of the hour. To keep this reasonable, David, I'll turn it back to you.
All right, Dave, thank you so much, and we appreciate you facilitating our Q&A and our discussion today. And of course, thank you to Carl for your great presentation. And at this time, I will turn it back over to Brian to wrap us up.
Hey, first of all, thanks. Two things. First of all, to thank everyone for this insightful series and this seminar in particular. Carl, really appreciate it. A lot of application and a lot of interest in it, obviously. Thanks, Dave, also for moderating, fielding the questions for us. And wanted to thank again the TerraWest team, David Lewis, who finally works with David, and without David and Malik, this would we wouldn't be able to pull this together. Thanks also to the participants. And last thing is, hey, we want to remind you that we will continue the weekly series, and 1 week from today, on Thursday, July 30th at noon Eastern, Bill Line, physical scientist from NESDA STAR, formerly Weather Service, is going to give us an overview of the derived motion winds and AWIPs with applications and how they could be used in forecast operations. So please watch for an emailer from the TerraWest team. They'll have the details on that, and we welcome and appreciate your continued attendance. Thanks, everyone. Have a great day.